Welcome to the deep dive. Today, we're jumping into the world of large language models, LLMs, specifically how you can really, control them.
Right, how to fine-tune their behavior.
Exactly. We've gathered some sources to help us unpack all the different, let's call them, dials and levers that shape what an LLM spits out, especially how this works within Snowflake. We want to get you that granular control.
Yeah, our mission today is basically to give you a shortcut. So you're not just aware of LLM parameters, but you really get why they matter for tailoring how these models respond.
So you can sculpt the AI's output.
Precisely, to get exactly what you need.
Okay, let's unpack this then, these LLM hyperparameters.
Yeah.
What are we actually adjusting here? What are these settings?
Fundamentally, they're the controls. The knobs you turn to influence how the LLM generates text. They control, well, pretty much everything.
Like how creative it gets,
Yeah.
or how long it talks for.
Exactly that. Creativity, length, even, whether it starts repeating itself. They're the key to making the AI behave the way you want it to. Let's start with model size. This is basically its scale, right? Usually measured in billions of parameters. Think of it like raw processing power.
Bigger model, bigger brain.
Sort of, yeah. Larger models generally handle more complex reasoning. They can grasp more nuance in your requests. You'd likely see a difference between, say, GPT 3.5 Turbo and GPT-4.
Right. GPT-4 usually feels a bit more sophisticated in its answers.
Exactly. It's often more nuanced, more detailed, partly because it's just bigger, more complex.
Okay, so size matters for complexity. What is this context window?
Right, the context window. That's the maximum number of tokens, pieces of words, basically, that the model can look at one time. And that includes your input and its output together.
Okay, so input plus output.
Combined, yeah. So, for example, GPT-4 might have around, say, 16,000 tokens. But then you look at something like Claude 3, and it's huge, maybe 200,000 tokens.
Whoa, 16K versus 200K? That's a massive difference. What does that let you do?
Well, with a bigger window, the model can handle whole documents, long articles, or keep track of a really extended conversation without forgetting what you talked about earlier.
Like giving it a better short-term memory.
That's a great way to put it.
Yeah.
Then there's the number of tokens, or max tokens. This one's pretty straightforward.
Just tells it when to stop talking?
Pretty much. It controls the maximum length of the generated output. Set max tokens equals 100, and boom, it stops after 100 tokens. Keeps things short and sweet, if that's what you need.
Yeah.
Now, temperature. This one's really interesting. It controls randomness.
Randomness, how so?
Well, a lower value, like temperature equals 0.2, makes the output more focused, more deterministic, really predictable, perfect if you need, say, factual answers.
Okay, like summarizing a report or something.
Exactly. But if you crank the temperature up, maybe temperature equals 0.9, you encourage more creativity, more variety in the responses.
So that's for brainstorming.
Yeah.
Or writing a story.
Precisely. Ideal for creative tasks. Generating ideas, writing marketing copy, that kind of thing.
So if I'm doing that financial summary, I keep temperature low. Low for facts. But if I need, I don't know, catchy slogans, I turn it up. Are there like pitfalls? Can you mess it up?
You've got it. Low for facts to avoid, well, making things up, hallucinations. High for creativity. Yeah, a common mistake is pushing it too high, maybe over 1.0. Sometimes the output can get really weird, like nonsensical. So it's a balance. Okay, next up. Top K sampling. This one limits the model's choices for the next word. It only considers the K most likely options.
So fewer options means less random.
Generally, yes. A lower K means more deterministic output. If you set top K 50, it only picks from the top 50 most probable next words. It balances, diversity and relevance a bit. And related, there's top or nucleus sampling. It's a bit different.
How's Copic different from Top K?
Okay, think of top K like this. It always looks at a fixed number of top options, say the top 50.
Yeah.
Top K is more dynamic. It selects the smallest group of top words whose combined probability adds up to at least P. So, if top equals 0.9, it looks at the most likely words until their probabilities sum up to 90%. Sometimes that might be just a few words, other times it might be more.
So it adapts based on how sure the model is.
Exactly. It often leads to more natural, less robotic-sounding text, especially for creative stuff. People often prefer top-up for that fluidity. Top K gives more direct control over the number of choices. Top controls the probability mass. Then you have stop sequences. These are just specific words or characters that tell the model, okay, stop generating now.
Like a keyword to make it stop.
Yeah. For instance, you could set stop nen, N. The model stops if it generates a new line or the word end. Super useful for getting structured responses like lists or just making sure it doesn't ramble on.
That is clever, like putting brakes on it.
Right. And we also have frequency penalty. This one discourages repeating the same tokens too often in the output it's currently generating.
This doesn't sound like a broken record.
Exactly. Setting something like frequency penalty equal 0.5 makes it less likely to repeat words or phrases. Helps keep the text varied. And finally, presence penalty. Similar, but different. It penalizes tokens that have already appeared anywhere in the conversation history, not just the current output.
Okay, so frequency is about recent repetition, presence is about overall repetition.
Got it. Presence penalty, say presence penalty equals 0.6, encourages the model to introduce new topics or concepts rather than sticking to what's already been discussed. Makes for richer, more diverse conversations.
Wow, okay. That is a lot of control. It really does feel like tuning an instrument. So the big question, especially for folks using Snowflake, how do these apply when you're using Snowflake Cortex, the built-in stuff?
Right, and this is a really important point from the sources. While these parameters are super powerful, many of them, they're just not configurable in the standard Snowflake Cortex SQL function.
Wait, really? Which ones?
Quite a few, actually. Model size, context window, max tokens, temperature, top K, top, stop sequences, and even the frequency and presence penalties. None of those are settings you can directly tweak in the SQL functions.
Huh. That's quite a list of things you can't control. Seems like a big limitation if you need that fine-tuning. Why do they do that?
Well, it seems like a design choice for, simplicity. Cortex functions are meant to be easy to use right inside the database. They pre-optimize things, manage settings internally to give a consistent result without you needing to fiddle with everything.
Okay, so it abstracts away the complexity. Good for some users.
Definitely. Great for many common tasks. But like you said, if your specific case needs that really fine-grained control, that specific behavior, well, the built-in functions might not cut it.
Right. So if the built-in stuff is convenient but limited, what's the workaround? Do the sources suggest anything for people who need more dials?
They absolutely do. And this is where Snowpark Python comes in. The sources really emphasize using external LLM APIs, from OpenAI, Anthropic, Google, Mistral AI, those guys with Snowpark Python.
Ah, so going outside Cortex, but still within Snowflake using Snowpark.
Exactly. That's how you get that granular control back. Because when you use Snowpark Python to call these external APIs, suddenly you can configure many of those key parameters again, specifically temperature, top kick and top sap, stop sequences, and those frequency and presence penalties, they're back on the table, configurable.
Okay, that makes sense. Can you walk us through an example like that OpenAI one?
Sure. So imagine you write some Snowpark Python code like this. Response, OpenAI.chatCompletion.create, model GPT 3.5 turbo, messages role, user, content, tell me a story about space exploration, temperature 0.8, max tokens 300, top day 0.9, frequency penalty 0.2, presence penalty 0.3, stop the end.
Okay, break that down. What does each setting do to the story it generates?
Right. So temperature 0.8 means the story will be pretty creative, but hopefully not totally wild, a good balance. Max tokens 300 keeps the story to a reasonable length, about 300 tokens max.
Got it. Controlled creativity and length.
Yep. Then top 0.9 guides the word choices, keeping them within the 90% most likely option so that the story stays, plausible. It avoids weird tangents. Frequency penalty 0.2 gently discourages repeating phrases too much.
Keeps it from sounding repetitive.
Exactly. And presence penalty 0.3 encourages it to maybe introduce slightly new ideas within the story. And finally, stop the end. Super handy. It tells the model, literally, stop generating once you write the words the end.
Nice, clean ending. That really shows the level of precision you get back with this approach. You're really directing the AI.
That's the idea. Tailoring it precisely.
So what about flexibility? Can you easily swap between, say, OpenAI and Anthropic using Snowpark Python?
Oh, yeah, absolutely. Snowpark Python lets you integrate with lots of different external models. You mentioned OpenAI's GPT models, Anthropic's Claude 3, Google's Gemini, Mistral AI's models like Mistral Large. You can connect to them. And the sources even show you can build functions like a query model function to switch dynamically. You could pass in the same prompt, but tell it, okay, use OpenAI this time, or try Anthropic now, or let's see what Google does.
That's really versatile. Test different models, route tasks based on strengths. Cool.
Definitely. It gives you a ton of options.
So any practical tips or things to watch out for when integrating these different external models?
Yeah, a few key things. First, connecting them is usually done via REST API wrappers in Snowpark Python. Pretty standard stuff. Second, you can automate everything. Use Snowflake tasks, streams. You can trigger these API calls automatically. build proper applications.
Automating the external calls.
That's nice. Very powerful. But crucially, remember, each vendor is different. They have their own model names, their own API details, and importantly, they don't all support every single parameter we talked about.
Ah, okay. So Topgek might work with one, but not another.
Exactly. Or frequency penalty might be an option for OpenAI, but maybe not for a different provider, or it might be called something else. So you just need to check the specific documentation for the model you're using.
Good point. Check the fine print for each vendor.
Always a good idea.
Well, there we have it. We've gone from the basics of LLM hyperparameters all the way to fine-grained control within Snowflake using Snowpark Python and external models. It really feels like this knowledge gives you the power to get exactly the AI output you need.
Absolutely. And if you think about the bigger picture, really understanding this stuff, it changes you from just a user of AI into someone who can actually, sculpt what it does, an active participant.
So here's something to think about as you digest all this.
Okay.
What new things become possible for you when you realize you can genuinely tune your AI's voice, its creativity, its behavior, instead of just taking whatever default it gives you?
Yeah. What doors does that open?
Thanks for joining us on this deep dive. Keep exploring.